Welcome back. So let's do our hypothesis test for these carpeted and uncarpeted rooms. Do the carpeted rooms have more bacteria? That's what the researchers were interested in finding out. And we were to use the alpha equals 0.05 level of significance. So what are our hypotheses? Well, the null hypothesis is always that there's no difference between the two populations, in this case the two population means. Our alternate hypothesis, do carpeted rooms have more bacteria? Let's see, I've forgotten which population was which. Okay, that first column was the carpeted rooms, and I used X sub 1 and S sub 1 for that. So the carpeted rooms must be population 1. So we're investigating the hypothesis, is mu1 greater than mu2. That's our alternate hypothesis that we want to know about. Notice that's a right-tailed test. So when I look at my t-distribution, I'm going to be looking for area in the right tail. But I need my test statistic. So let's get that. So our formula for that is x1 bar, which is 11.2, minus x2 bar, which is 9.79, over the square root of S1 squared, so 2.667 squared divided by 8, plus 3.21 squared divided by 8. So crunch the numbers, run that through a calculator, and you'll get 0.954. So that's my test statistic over here, 0.954. We're looking at the t-distribution. You know that because we labeled it t. That's to help you know which distribution to use. And how many degrees of freedom? Well, what was our sample size? Here we go. What was our sample size? 1, 2, 3, 4, 5, 6, 7, 8 carpeted rooms and also 8 uncarpeted rooms. So they happen to be the same sample size. So 8 minus 1 is 7 degrees of freedom. Okay, if one of the sample sizes had been, say, 6, then I'd be using 5 degrees of freedom here. You'd take the smaller of the two. Okay, so looking at the table, so when you look at the table for 7 degrees of freedom, you're not going to find t-value 0.954 in there. So far what I've been doing is I've just been kind of picking the one that's the t-value that's closest to the one I want and saying, okay, my area is approximately, and then whatever I got there. But I want to point out just a slightly different approach. 0.954 is between two t-values that give me the larger one gives me 0.15 area, and the smaller one gives you 0.20 area. So instead of picking one, what you can do is say that the p-value is between 0.15 and 0.20. So again, if you look, when you're looking at the t-table, the two numbers on each side of 0.954 that are closest to it give you 0.15, and the other one gives you 0.20 for the area. So the area is between those, and maybe that's usually fine to just have that know that the area is between two numbers like that. You don't have to pick one and say area is approximately equal to either one. As long as you can tell from this whether or not your p-value is greater than or smaller than your level of significance. So we were being asked to use the 0.05 level of significance, and the question is the p-value bigger or smaller than that? Well, 0.15 and 0.20 are both bigger than 0.05. So whatever the p-value is, since it's between these two numbers, it's going to have to be bigger than 0.15, because every number between, 0.05, every number between 0.15 and 0.20 is bigger than 0.05. So from this we can confidently say the p-value is greater than alpha, the level of significance, even though I don't know exactly what the p-value is. Let's see, what do we do when the p-value is greater than the level of significance? Yes, that's correct. We accept, or rather, we do not reject H naught. So you always either reject or don't reject H naught. When the p-value is bigger than alpha, you do not reject it. That means we feel there's evidence to support H1, so we conclude there is sufficient evidence at the alpha equals 0.05 level of significance to conclude. So to conclude that mu1 is greater than mu2, but let's put that in words. What did that mean? Mu1 was the average bacteria population on carpet in carpeted rooms. Mu2 was the average bacteria population in uncarpeted rooms. So let's say it that way in words. To conclude that carpeted rooms contain more bacteria than uncarpeted rooms. Okay, so that's the hypothesis test. What we still need to do is a confidence interval. So we've we've used hypothesis testing to conclude that, yeah, carpeted rooms probably contain more bacteria than uncarpeted rooms. What we're going to do next with the confidence interval is we're going to estimate the size of the difference. Okay, so we'll come back and do that in the next video.